Hello, this is Mr. Collier, and today we're doing Spearman's rank correlation coefficient. Okay, so let's take a look at this here. The PMCC, Pearson's product moment correlation coefficient, the R value, can only indicate a linear relationship. So we have Spearman's in case there's something that's nonlinear. Okay, like this data here. It looks like a line wouldn't fit it quite well. It's a curve, but as you can see, as x increases, the y value also increases for all the points, so it looks like they're related. Okay, so we can't say there's a linear correlation, but there's definitely an association between the two variables. Okay, so if we calculate, so let's type that in and calculate the R value. So let me go to Shift Clear All and start typing and really make sure we got the right numbers here. It's very common to make a typo. Okay, so we got all the data in, and actually always check out symbol and make sure everything's okay. C1, C2 is linear. Actually, I'm going to click plot to make sure the data actually goes in there. Okay, so it looks good. And let's go back, and R value is right there. So you get an R value of this here, 0.961, but it's not quite linear. So if you want to think about, well, we know that looking at the graph, it should be like 1 if we're just talking about as one increases, the other increases, right? For every single point, we're always increasing, right? So it looks like there's definitely an association there, like 100% association. If we look at the ranks, so that's what Spearman's rank is. Spearman's rank correlation. Instead of R, we use the symbol RS to indicate Spearman's. So Spearman's looks at just the ranks. So like first, second, third, fourth, fifth. So we rank them. You can go from lowest to greatest or greatest to lowest. In this table, they're starting with the greatest value. So let's check that out. So for the x values, 8 is the largest. 6.72 is the next one. So actually it's a bit disorganized, but I think that's corresponding to this one here. 2, and this is 3 is the very first one. And this is 4. And this is 5 here. And this is 6. And this is 7. Did I mess something up there? And this is 8. So let me just redo that because I think I messed something up. So it goes 3, 8, 7, 5, 6, 2, 4, 1. And we did save the y values. So let me do it up here first. So we got 1, 2, 3, 4, 5, 6, 7, 8. So it's 3, 8, 7. Oh, it's the same. Exactly the same thing, which matches what we did up above, right? So I could type that into the calculator, but I know anyway if I type that into your calculator, the R value for the ranks is actually equal to Spearman's for the original. The Spearman's rank correlation coefficient is exactly 1. Which is what we see. We see that every single time that when there's an increase in the x, there's an increase in the y. So Spearman's rank correlation coefficient is exactly 1. Okay. So comment on your result. So this means there is a perfect positive association between x and y. Or you could say the correlation between their ranks is a perfect positive correlation between the variables, I'll say. Okay, let's take a look at this example. And it doesn't look linear. You have definitely an outlier. But if we look at the ranks, let's check it out. Let's check out the ranks. So let's do the ranks. And over here, I'm going to get the biggest one is here. 1. Then we have 2, 3, 4, 5, 6, 7, 8. It goes like that. And then for this set of data, it goes 1, 2, 3, 4, 5, 6, 7, 8. Okay, so this goes 8, 7, 6, 5, 4, 3, 2, 1, and this one is 2, 1, 3, 4, 5, 6, 7, 8. So we can see the graph here already. It looks like these values are decreasing as T increases, Y decreases. As temperature increases, the area of the Petri dish discovered after 48 hours is recorded. So the area decreases. Okay. So let's type those data values in, just the ranks. So to clear that, and type in 8, 7. Perhaps I should go back to symbol and make sure you click plot to make sure it goes in there. Go back to apps, statistics, stats. You get an R value of negative 0.976. Okay, so that is Spearman's rank, negative 0.976. So we get a negative number because the values are decreasing. As T increases, Y decreases in general. Okay, that's what I basically answered part F. RS is negative. I'm very close to -1, so it's a very strong positive association. Okay, so the values, or I'm going to say as T increases, Y decreases. So we have negative Spearman's rank. Spearman's rank coefficient. Okay, so what are the differences? Well, RS is useful, or useful, I'll say, for non-linear relationships or associations. I'll say relationships. Okay, also RS isn't affected so much by outliers. Okay, like this outlier up here, didn't matter so much that it was way down, and still the rank was the lowest one. Didn't matter. It's not affected by outliers. Okay, so RS, Spearman's rank, measures whether the relationship is monotonic. That means as one increases, the other increases, or as one increases, the other decreases. Doesn't matter if it's linear or not. We do not say strong correlation between X and Y. We just say there's a strong positive or negative association between the variables, or a correlation between the ranks. Okay, now let's look at another example. If we have the same value, we got to find their average rank. Okay, so let's check out this one here. So if you want to make, let's do the ranks up on the top and the bottom. So we have the X values. This is number 1. Oh, sorry, this is number 1. This is 2. And this is 3. Now there's 2 4s. So they would normally be 4 and 5. So these are the average of 4 and 5, which is 4.5. Okay, and then that would be 4 and 5, so the last one would be 6. And we can do the same thing down here. 1 for the largest one, 2. Now these are both 3, so it would be like 3 and 4, or 3.5, which is the average of them. I missed 8. Oh no, so we're going backwards. So this is 4, 5, so this is Sorry, 1, 2, 3, 4, 5, 6. Okay, and then you can get the Spearmans rank coefficient from that. So we go and just type in the ranks. Okay, let's go back to symbol, plot, make sure it's plotted. And then go over here, and R is negative 0.956. So the Spearman's rank is negative 0.956. So it's a very strong negative association between the two variables.